Hello students, welcome to the lecture on tools and techniques for quality management. Now after this lecture, we will be able to learn the following objectives. Define quality function deployment, explain QFD methodology, discuss failure mode and effect analysis, explain benchmarking for TQM. Let's start with the introduction. The TQM is a management philosophy that seeks to integrate all organizational functions, marketing, finance, design, engineering and production, customer service, etc. to focus on meeting customer needs and organizational objectives. The TQM views an organization as a collection of processes. It maintains that organization must strive to continuously improve these processes by incorporating the knowledge and experiences of workers. The TQM is the foundation for activities which include commitment by senior management and all employees, meeting customer requirements, reducing development cycle times, just-in-time or demand flow manufacturing, improvement teams, reducing product and service costs, systems to facilitate improvement, line management, ownership, employee involvement and empowerment, recognition and celebration, challenging quantified goals and benchmarking, focus on processes or improved plans, specific incorporation in strategic plan. Let us now discuss quality function deployment. Quality must be designed into the product, not inspected into it. Quality can be defined as meeting customer needs and providing superior value. Quality function deployment, QFD, is a structured approach to defining customer needs or requirements and translating them into specific plans to produce products to meet those needs. Definition of QFD. The QFD stands for Quality Function Deployment. Quality Function Deployment, QFD, systematic way for developing products based on the needs of the customer. It is a structured product development process which translates what the market requires into a program to create, manufacture and deliver it. In a QFD process, multi-skilled teams collaborate to arrive at a common understanding of the customer needs and determine the appropriate technical requirements of each stage. There is no single or unique definition for quality function deployment, QFD. But a general basic concept of this method is as follows. QFD is a system with the aim of translating and planning the voice of the customer into the quality characteristic of products, processes and services in order to reach customer satisfaction. QFD is not only a quality tool but also an important planning tool. It allows the consideration of the voice of the customer along the service development path to market entry. Competitiveness. Three aspects are especially important for the development of firms' competitiveness. They are quality, cost and opportunities. The quality lever. The quality lever is a concept that helps to visualize the effects of the development stage and how they affect the quality of the product serviced. The idea is that improvements carried out in the production phase can lead to a lower cost-benefit ratio when compared to the increase of the service quality. Objectives of QFD. The three main goals in implementing QFD are prioritize spoken and unspoken customer wants and needs, translate these needs into technical characteristic and specification, build and deliver a quality product or service by focusing everybody toward customer satisfaction. Process of QFD. The QFD uses some principle from concurrent engineering in that cross-functional teams are involved in all phases of product development. Each of the four phases in a QFD process uses a matrix to translate customer requirements from initial planning stages to production control. Phase 1, product planning. Building the house of quality led by the marketing department. Phase 1 or product planning is also called the house of quality. Phase 2, product design. This phase 2 is led by the engineering department. Product design requires creativity and innovative team ideas. Product concepts are created during this phase and part specifications are documented. Phase 3, process planning. Process planning comes next and is led by manufacturing engineering. During process planning, manufacturing processes are flow charted and process parameters or target values are documented. Phase 4, process control, and finally, in production planning, performance indicators are created to monitor the production process, maintenance schedules, and skill training for operators. Benefits of QFD. Applying QFD is quite simple but provides detailed results. Benefits derived from QFD application in firms are listed below. Preventive design. The biggest advantage of QFD is that it promotes the development of services in a proactive way. Reduction of development time. QFD application allows reducing costs and the time needed to introduce the new service into the market. Client satisfaction. QFD is oriented to the voice of the customer and not to the thoughts of the developer. QFD as a tool or system. Smith and Angeli determined 3 components of total quality management, TQM. In this type of classification, QFD was considered as a tool or quality improvement tool. However, in the following, it is specified that depend on its application and due to its systematically process, QFD must be considered both as a tool and as a system. History of QFD. The QFD history belongs to originally developed by Yoji Akao of Tokyo in 1966, first implemented at the Kobe shipyard of Mitsubishi in 1972, subsequently adopted by Toyota and other Japanese firms. First QFD training outside Japan at GM and Ford in 1972, later by other companies around the world.
Hi all, now in this video we are going to talk about quality function deployment, one of the most frequently used tools in design for Six Sigma. And in this video we'll talk about what quality function deployment is, where can we use that, and what are benefits of quality function deployment. And then later on we will see how do we use quality function deployment in our real life. We'll see a couple of examples. Okay, so this quality function deployment was developed by famous Japanese planning specialist Yoji Akao in 1966. Okay, at that point in time, most of the companies in Japan, they were using statistical approaches to improve quality of their products. But Mr. Akao was willing to develop a quality assurance method that would design customer satisfaction into a product before it was manufactured. Okay, so basically he developed a quality function deployment wherein we use this tool, we use quality function deployment to transform what customer wants into how that will be delivered to customer. Okay, in another word, you can say that this helps us translate voice of customer into voice of engineer. Okay, what customer wants, how are you gonna deliver that? Mr. Akao, in most of his speeches, right, he often used to say that there was a time when a man could order a pair of shoes directly from the cobbler. And by measuring the foot himself and personally handling all the aspects of manufacturing, the cobbler could assure the customer would be satisfied. But in today's scenario, the situation is different. Okay, all the companies generally they produce mass products, and the growing distance between producer and consumer is also a growing concern. So in this scenario, you will have to ensure, if you want your customers to be satisfied, you will have to ensure that your product contains those all parameters that will make your customers feel happy. All right. So in quality function deployment, just give me 1 second. Okay, in quality, we know in every process there will be certain input, and with the help of certain procedure and resource, it will produce output, right? And in every process, controlling the output has always been a challenge, right? So quality function deployment will help you control the output of a process. It will help you define the input that you need wherein you have a specified output. Let me give you an example when I say that. Let's say you want a product, right? You want one mobile phone. Your company is going to launch one mobile phone. Now you're sure that you will be giving certain features, okay? Certain features that every mobile company gives, certain competitive advantage, certain features that other companies do not give, right? So first you will make a list of CTQs that will help your customers feel happy. Okay, this is the very first step of quality function deployment. Make list of CTQs, make list of customers' requirement that will make your customers feel happy. The very second step in quality function deployment is to ensure to prioritize those all CTQs, because all CTQs cannot be equally important. Okay, so you will have to prioritize those CTQs. And then the third aspect is to convert those all CTQs into engineering aspect, or being bit non-technical. I would say the third step would be to convert those CTQs into how you are going to deliver those CTQ. For example, if your CTQ is that you need to provide, say, camera phone in the mobile. Okay, though it's very common now. So how you are going to provide that feature of camera phone? So that becomes how to deliver part. Okay, we'll see example, but now let's try to understand what are the scopes of quality function deployment. Where can we use quality function deployment? See, this is a quality function deployment is a process designing tool. You can use quality function deployment whenever you are designing a new process or you are changing a process. Okay, so you can use quality function deployment to design a product when you are changing product, or say you are making a completely new product, or say you are adding certain features. So whenever you are designing a new product, right, you can use quality function deployment. Secondly, you can use quality function deployment if you want to design a new process. Let's say your company, you work for one call center, for one BPO, and your company has got one new client, right? So you need to design a process according to your client's specification, according to your client's requirement. So therein you can use quality function deployment to design a process that serves your client's interest. Okay, and obviously it will help you in designing product requirement.
Let us now discuss QED methodology. The QFD methodology is based on the development of a series of matrices called House of Quality. The structure of these matrices are the House of Quality. This matrix is called House of Quality due to a roof-like structure in its top. This house can be divided into rooms. Customer requirements, CR. It is known as voice of customer, or VOC. They are the what's the customer want from the product to be developed. They contain customer wishes, expectation and requirements for the product. Customer importance ratings. Once these what's are in place, the customer needs to provide numerical ratings to these what's items in terms of their importance to the customer. Customer market competitive evaluation. In this block, a comparison is made between a company's product or service and similar competitive product or services on the market by the customer. Technical specification. They are the technical specification that are to be built into a product with the intention to satisfy the CR. They are sometimes referred as house because they are the answer to CR. How can the requirements be addressed or satisfied? Relationship matrix. Relationship matrix is used to maintain the relationship between CR and design requirements. Correlation matrix. It is a triangular part in the HOQ, the roof. The correlation matrix is used to identify which house items support one another and which are in conflict. Target goals. Completed by technical team. These are the how much of the technical house items. Technical difficulty assessment. Technical team conducts the assessment. It helps to establish the feasibility and reliability of each house item. 1 to 5 ratings are used to quantify technical difficulty, with 5 being the most difficult and 1 being the easiest. Technical competitive evaluation. It is used for comparing the new product with competitors' products to find out if these technical requirements are better or worse than competitors. Importance ratings. This is a final step of finishing HOQ for phase 1. For each column, sum all the raw numbers, each of which is equal to the production of relationship, rating and customer's important rating. Voice of the customer, VOC. The QFD starts with the establishment of objectives which represent the answer to what, What is desired in order to reach the new service? Development. These objectives derive from clients' requirements and are called the voice of the customer. Design requirements. After completing the client's requirements list, what comes the definition of how? The how are the design requirements of the service. It is necessary to define how each client's requirement will be satisfied by the service. These are measurable features that can be evaluated at the end of the development process. Now let us talk about the failure mode and effect analysis. Failure modes and effect analysis (FMEA) is a systematic, proactive method for evaluating a process to identify where and how it might fail and to assess the relative impact of different failures in order to identify the parts of the process that are most in need of change. The FMEA includes review of the following: steps in the process, failure modes, what could go wrong, failure causes, why would the failure happen, failure effects, what would be the consequences of each failure. Background. Failure modes and effect analysis (FMEA) was developed outside of healthcare and is now being used in healthcare to assess risk of failure and harm in processes and to identify the most important areas for process improvements. General instruction. Step 1. Select a process to evaluate with FMEA. Step 2. Recruit a multidisciplinary team. Step 3. Have the team meet together to list all of the steps in the process. Step 4. Have the team list failure modes and causes. Step 5. For each failure mode, have the team assign a numeric value known as a risk priority number of RPN for likelihood of occurrence, likelihood of detection, and severity. Step 6. Evaluate the result. Step 7. Use RPNs to plan improvement efforts. FMEA methodology. In order to perform a FMECA, the analyst must perform a FMEA first, then the CA. The FMEA will then be used as a foundation of the criticality analysis. The FMEA will identify systems and/or components and the associated failure modes. This part of the analysis will also provide an assessment of the cause and effects of each failure mode. Define the system to be analyzed, functional or hardware approach. Provide semantics and operational detail of the system. Clarify the mission of the system of the ultimate goal of the system. The mission may be to provide emergency power or maintain a certain temperature to the facility. Fault tree analysis (FTA). A fault tree analysis (FTA) is a deductive top-down method of analyzing system design and performance and is sometimes used in QRA. It involves specifying a top event to analyze, such as a fire, followed by identifying all of the associated elements in the system that could cause the top event to occur. Fault trees provide a convenient symbolic representation of the combination of events resulting in the occurrence of the top event. Events and gates in fault tree analysis are represented by symbols. Benchmarking is a way to go backstage and watch another company's performance from the wings, where all sage tricks and hurried realignments are visible. Below are some question and assumption. What does that organization do that gets results so much better than ours? The answer to this question opens door to benchmarking, an approach that is accelerating among many firms that have adopted the total quality management (TQM) philosophy. The essence of benchmarking. The essence of benchmarking is a continuous process of comparing a company's strategy, products, processes with those of the world leaders and best-in-class organization. The evaluation of benchmarking. The method may have evolved in the early 1950s when W. Edward Deming taught the Japanese the idea of quality control. Other American management innovation followed. The Xerox case. The company invented the photocopier in 1959 and maintained a virtual monopoly for many years thereafter. Xerox became a generic name for all photocopiers. Levels of benchmarking. There are 3 levels of benchmarking: internal benchmarking within the company, competitive or strategic benchmarking, industry and competitors, benchmarking outside the industry. Development of benchmarking. Benchmarking or development activity is important in achieving best value both at a scheme and organization level. If we wish to benchmark our development program, then we recommend SDS Catalyst. Catalyst is an online subscription club which provides reports on scheme data and collects staffing and organization data, offering members various annual reports which highlight the efficiency of our organization with a comprehensive collection of KPIs. Types of benchmarking. Benchmarking is a very versatile tool that can be applied in a variety of ways to meet a range of requirements for improvement. Standard benchmarking terms include strategic benchmarking, performance benchmarking or competitive benchmarking, process benchmarking, functional benchmarking or generic benchmarking, internal benchmarking, external benchmarking, international benchmarking. Processes involved in benchmarking process. Benchmarking is not the same thing as a fame trip or getting a show around another business, which can of course be valuable in its own right. No, process benchmarking is never an ad hoc activity and instead is a structured process whereby we seek to compare one of our key processes or part thereof against what is deemed a best-in-class company so that we can learn how to do things better and apply that knowledge to our own process. To examine what we need to do to get the most from process benchmarking, consider it from 3 perspectives: before the visit, during the visit, and after the visit.
Benchmarking has a long history going back to the early days of evolution. Comparison has always been the essence of winning. And being able to react quickly and appropriately has helped man overcome significant hurdles. Since then, benchmarking has evolved, but it is still an integral part of our daily lives. Benchmarking is an activity that tells you your position or status by comparing yourself to others. The reason for comparing is to understand where you are today and what might be some of the areas that you need to improve. In business today, it is vital that we compare ourselves to others. We need to know, am I making more money than my competitors? How does my business compare to the rest within the same industry? Are there others out there that have similar problems? Have they solved them already? If yes, then what worked for them? Am I the top or the bottom of the class? Comparisons are great. However, there is a catch: only things that are comparable can be compared, if the result is to be useful. When these comparisons are done correctly, it is called benchmarking. First, you need to define what you want to benchmark. For example, benchmarking your financial performance, brand reputation, staff motivation, etc. Second, define appropriate comparators. We call them key performance indicators, or KPIs. Some KPIs for financial performance could be sales, margin, productivity. Third, ensure that your comparisons are comparable. We do this by defining segments within a network. For example, it might not make sense to compare a store in metropolitan Sydney to a store in regional New South Wales, so we would divide or segment stores based on their location. Fourth, gather data in an independent manner, and make sure it is consistent. We do this by automatically collecting and mapping your data into a standard chart of accounts. And lastly, produce customized and meaningful reports that are not only simple to understand, but show you your improvement over time. Once benchmarking has been successfully implemented, it becomes a powerful tool that helps you gain a deeper understanding of business performance in all aspects, including sales, margin, staff productivity, expense management, and efficiency.
Poka Yoga. Shigao Shinko introduced the concept of Poka yoke in 1961 when he was an industrial engineer at Toyota Motor Corporation. The initial term was Baka yoke, which means fool-proving. In 1963, a worker at Arakawa Body Company refused to use Baka yoke mechanism in her work area because of the term's dishonorable and offensive connotation. Hence, the term was changed to Poka yoke, which means mistake proving. Poka yokes are mechanisms used to mistake proof an entire process. Ideally, Poka yokes ensure that proper conditions exist before actually executing a process step, preventing defects from occurring in the first place. Where this is not possible, Poka yokes perform a detective function, eliminating defects in the process as clearly as possible. The Center for Excellence in Operations (CEO) has developed a Poka yoke framework to help its clients understand the various classification and application of mistake-proving mechanism. Brief overview of the framework is as follows. Prevention-based Poka yokes. Prevention-based mechanism sense an abnormality that is about to happen and then signal the occurrence or halt processing depending on the severity, frequency or downstream consequences. There are two approaches for prevention-based Poka yokes. Control method. This method senses a problem and stops a line or process so that corrective action can take place immediately, thus avoiding serial defect generation. Warning method. This method signals the occurrence of a deviation or trend of deviation through an escalating series of buzzers, lights or other warning devices. Detection-based Poka yokes. In many situations, it is not possible or economically feasible to prevent defects, particularly where the capital cost of the Poka yoke mechanism far exceeds the cost of prevention contact method. This method detects any deviation in shape, dimensional characteristic or other specific defects through mechanisms that are kept in direct contact with the part. Fixed value method. This method is used in operation in which a set of steps is sequentially performed. The fixed value method employs automatic counters or optical devices and controls the number of moves, rate and length of movement as well as other critical operating parameters. Motion step method. This method ensures that a process or operator does not mistakenly perform a step that is not part of the normal process. Levels of Poka yoke. There are 3 levels of Poka yoke and they are as follows. Elimination of spills, leaks, losses at the source or prevention of a mistake from being committed. Detection of a loss or mistake as it occurs, allowing correction before it becomes a problem. Detection of a loss or mistake after it has occurred just in time before it blows up into a major issue, least effective. Now in the end, let us summarize what we have learned in this lecture. The best Poka yoke in the world is a robust design. Many of the needs for Poka yokes are attributable to poor design and unrepeatable processes. Many people think of Poka yokes as limit switches, optional inception system, guide pins or automatic shut-offs that should be implemented by the engineering department. The key task for the process owner is that they lead the visit professionally and ensure that the required information is addressed in its entirety so that the goal of the benchmarking visit is fully achieved. Globalization and advances in information technology are increasing opportunities for international projects. The quality lever is a concept that helps to visualize the effects of the development stage and how they affect the quality of the produced service.